Hello, everyone. Thank you for staying with us today. I'd like to welcome to our virtual stage Jordan Volz, Director of Field Engineering with Continual. Jordan, the stage is yours.
Thank you. And thanks for having me on this platform. It's great to be able to come and talk to you guys and gals. Brief introduction about myself. I'm the Director of Field Engineering at Continual. Academically, came up through pure mathematics, ended up getting into the tech industry a little bit over a decade ago. And I've had a variety of roles, everything from software engineering to system architect to data scientist. So I've had a lot of different viewpoints into how companies build and run and implement their data teams and their data strategies. And we'll be sharing some of that insight today. Today, we're going to be talking about AI for the modern data stack. Agenda-wise, I'm not assuming you know what the modern data stack is. So I will, do a short explanation of the modern data stack. We'll then talk briefly about why AI is a good fit for the modern data stack, which I think is possibly non-obvious. And then I'll provide a quick introduction to Continual. I know there's a break after this as well, and if, like me, you're on the East Coast, it's already getting pretty late in the day. I probably won't use the entire time for my presentation, so we'll leave ample time for questions at the end if people have it, or if they want to take, extended break and get coffee as well. It'll be great either way. All right, so let's talk about the modern data stack and how we got here. You can kind of view the evolution of the data platform over time. And this is something I've spent a lot of time thinking about in my career. But, 1970, Edgar Codd famously wrote a paper, The Relational Model of Data for Large Shared Data Banks. And that really is what set off, the original database management system wars around like IBM, Oracle, Microsoft, Teradata, SAP, companies like that. Between, really took like a decade to actually commercialize a lot of these ideas into like software for companies. Back in the day, you were actually going from like zero to actually having data and starting to analyze data. So there was a non-trivial hump to get over. So it took about a decade, but by the time the 80s were rolling, this was kind of a thing that people were doing. And I'd say up until the turn of the century, these were really still the main players in the data management market. We then, in the next decade, saw the rise of a new form of technologies called different things: big data, distributed SQL, NoSQL technologies. It was stuff like Hadoop, Vertica, MongoDB, Greenplum, Netezza. These are all technologies in the space, and it really grew out of the need for some companies to address both larger amounts of data and larger variety of data. So, as technology advanced from 1980 to 2000, you now saw that companies were doing things like they had websites where they did in 1980. And moving further along, things like mobile devices became important, and so data types started to become more diverse. You have images, video, larger text documents, stuff like that, and you just have a lot more data being created because now you have user-generated content. So these systems were set out to address a lot of those types of things. I worked at Cloudera for a number of years, who's the main Hadoop vendor. And we, tackled a lot of these problems with our data platform. Unfortunately, for some of the people in this market, what happened in the next decade was really the rise of cloud. So a lot of this big data technology was really funded on the premise that you were still going to store data, on premise in a data warehouse, or a data warehouse that you're managing, your IT team is managing. So the 2000s really saw the rise of cloud. So AWS, Google, Microsoft, obviously being the major players. But in particular, I think cloud data warehousing is really going to, be what people remember this decade by the most. So it's people like Snowflake, who is, of course, now very popular and widely penetrated in the market, but also Amazon has Redshift, Google has BigQuery, Azure is pushing Snaps, and I would say even, Databricks has a SQL offering, and they're a player in this market as well. And so like you kind of come around in a way back to the SQL world where during the transition into the big data landscape, I think a lot of people got away from working with data purely in a SQL fashion. And you started seeing people use things like MapReduce and Spark, and you're now writing code to operate on data. And that is unfortunately just a more complex and more challenging thing for companies to deal with. So over time, we start shifting back to SQL as, it's a much more user-friendly way to interact with data. So I think cloud data warehousing really is here to stay, and I'll be surprised if SQL gets dethroned in the near future by anything as the main language of data, so to speak. What does this have to do with the modern data stack? The modern data stack really evolved out of this focus on the cloud data warehouse. In very simple terms, the modern data stack is essentially a collection of tools that are just centered around your cloud data warehouse. So we can look at over time how this has evolved. Early on, you had the cloud data warehouses themselves spinning up. So BigQuery was 2010, Redshift and Snowflake 2012. After that, you get things like your BI tools running on your cloud data warehouse. So Chartio, Looker, Mode, Metabase, Redash, those have all been popular tools in the space, as well as your data integration tooling like Fivetran, Segment, and Stitch. So these were all in the first half of this decade. After that, you then start to look at, okay, it would be cool if we had data transformation tools that were very specific to this ecosystem. So dbt is a very popular open source technology. Dataform was another technology that got spun up later that Google has acquired. So that really provides a very nice core set of tooling to work with data and to analyze data all within the cloud without managing anything. It gives you a lot of great capabilities. The ecosystem continues to evolve. So we've seen things like Census and HighTouch have come out, which are reverse ETL tools. So essentially, how do I take data out of my data warehouse and put it back into applications that end users are going to be consuming? That's what those do. And then, as customers get more sophisticated, they need tooling around governance and data observability and stuff like that. So there's a number of tools in the past 4 or 5 years that have come out to address some of these types of problems. So I think one thing that's interesting to think about is can we concretely define the modern data stack, or can we look at what are the common trends or the common threads that exist within this ecosystem? And on the right here, we have just a sample architecture. So basically the simplest architecture you have. Fivetran here would be your data integration tool going into your cloud data warehouse, which in this example is Snowflake. dbt would be running transformations on Snowflake of creating new tables and new views. You would have people using a BI tool like Mode to create dashboards and do various analyses on your data. And then a tool like HighTouch would be able to ETL it back out into your own applications, or reverse ETL it in your own applications. And then, what are the common threads? I think on the left here, these are the main things that if you look across all the tools in the ecosystem, these are the things that appear in most of them. So it's important to be cloud native, obviously, because the cloud data warehouse is the center of your world in this ecosystem. Ease of use is number one. Ease of use is, as I talk to more and more customers who are in this paradigm, it's largely a lot of organizations who are trying to be cloud native as much as possible, or trying not to employ dozens of people to maintain their cloud stacks. So the easier things are to use, the more they can get with fewer resources. And that is very appealing. So you can go to a tool like Fivetran and you can start getting data from Salesforce, into Snowflake, in a day or two. And that is, I think, super appealing to anybody who's been working in data for decades, and you work on database migrations, and they take months and months and months, if not years of time to get stuff from one point to the other. These tools offer a very streamlined approach. And within this ecosystem, I think this is very important. SQL is really the main language that these tools use. So the idea is that by focusing on SQL, you're widening your audience who can use and support these tools. And by doing so, you're getting the most bang for your buck out of your organization. So if I give you a tool where people have to use Python or people have to use R in order to really make use of it, I'm going to find people who can do it. But if I focus on SQL instead, we're then going to find an even larger group. So ideally, SQL allows us to reach the most users in a very user-friendly fashion. A result of that is that we're really democratizing data. So I like to try to think of your data workflows as being, essentially those where you can get the most people who have the most data knowledge in your organization working on those problems. So to me, it should be less about like, are you a data engineer? Are you a data analyst? Are you a data scientist? Just like, do you understand the business and the data? And those people should be able to go to like any tool that your data team uses and use it to accomplish the goal, like whether that's a transformation or running a dashboard or any other kind of data analysis, or we'll talk later about like actually running like machine learning problems. And then lastly, I think a key thing about all these tools is they're built for automation. They're built to be operational. So a big thread in this ecosystem is that these tools are built for production. They understand that the end goal is to get use out of your data, and they want to automate that as fast as possible. So like if I'm moving data, as our previous example, I'm moving data from Salesforce to Snowflake. How do I do that in the shortest amount of clicks? Like, how do I make that as fast as possible to the user? That happens if I'm very opinionated on how this happens. So by being more opinionated, you're able to really streamline these things as much as possible, and you're able to give users a much better workflow. So we can look at the current state of the modern data stack and kind of like what are the different use cases we can solve. And we're going to kind of juxtapose this with hopefully something that is kind of well known in this crowd, which is like the data science hierarchy of needs. So bottom layer is, depending on who's writing it, either data collection or data storage. So in the modern data stack, you have a variety of tools available to choose from for data collection. In our previous diagram, we had used Fivetran, but you also have tools like Segment and Stitch that you can use for this. Storage layer, you're picking your data warehouse of choice. Here we have Snowflake, BigQuery, and Redshift. dbt has really emerged over time as the main transformation tool. Very rarely I see anybody not using dbt. And then for data analysis, lots of BI tools are available. Looker and Mode tend to be very popular for cloud savvy customers. Larger companies have probably been using Tableau for a while, and that still is a fairly popular tool in this ecosystem. So that is that's kind of how this rolls up. And so to date, the focus has really been on kind of this data analytic workflow or this data analytic stack. And juxtaposing with the data science hierarchy of needs, you probably know that the top of this pyramid is like machine learning or AI, and there's really nothing in this ecosystem right now that addresses that particular need. So keep that in mind, and we'll come back to that in a couple of minutes. Okay, so this slide is usually like the why do you care about AI slide. Hopefully with this audience, I don't really need to belabor this point too much. But the idea is, with AI, you're unlocking a lot of new use cases, right? So AI gives you the ability to solve a lot of stuff that you're not going to solve with traditional analytic approaches. So can I predict customer churn? Can I predict whether or not leads are going to turn into customers? Can I forecast sales for the next quarter, for the next year, for the next 5 years? Can I look at the lifetime value of my customers? Can I forecast inventory in my stores, in my distributors? Can I segment my customer base by different categorizations? Like, you can think of kind of, I think, talented data scientists can go in any business and probably think of dozens and dozens of use cases fairly easily that can, right now impact your business. So, hopefully I don't have to sell you guys on the value of AI here too much. I think a nice question is like, why would you use the modern data stack for AI, right? So like, what about this makes it ideal for AI? And I think it's actually super enticing for AI use cases because I think, just naturally the way it has evolved, it provides a lot of really great benefits that alleviate a lot of pain points for data scientists. And the first one is that data is actionable. So a key thing about modern data stack, if you like go online and start reading about it, is like one of the main goals is to make data actionable. And I think like analysts generally do a very good job of this, where they are very good at curating data sets and getting them into very nice formats and very nice slices that are then easily consumable by applications or by reports or what have you. And kind of the number one thing data scientists like historically complain about is that when they go to start a problem, like they don't have the data they need, the data's in a bad format, the data they want is across like 25 different tables. So like this data is actual problem is actually one that is, in my opinion, at the heart of a lot of machine learning problems, that you go to start a problem and you spend like weeks and weeks understanding the data and like figuring out like, okay, why don't we have data that's like, profiling our customers better, profiling our sales better, like doing whatever. Like no one has done this work before, so the data science isn't doing it. So in the modern data stack, they're very good at solving this problem and getting data into the state where it's immediately actionable. And in my mind, that means the data scientist is doing a lot less work, whatever they need to start a problem. Secondly, easy to get new data. So we have a variety of tools in the ecosystem, like we talked about, that make ingesting data easy, moving data around very easy. So if we have data in one system and we need it in another system, the data warehouse is at the center of everything. So it's very easy to get data there. And once it's there, I can then start building my use cases off of it. So again, not having data is one of the key complaints I hear about from data scientists. So I think this is very appealing that, assuming the data exists somewhere, it should be fairly easy to get it into my data warehouse in a short amount of time. And then, we talked about how SQL is at the heart of the modern data stack. This means that users have a very wide, that you have the ability to open up the system to a wide user profile. So I'm not locking my machine learning workflows behind Python expertise or behind R expertise or SAS expertise or like whatever tools that you use. You can say like, as long as you know SQL, which I think is a fairly good language for just broad data access, users can come and they can start using the system. So I think that means you're bringing more people to the table to work with these workflows, and they're bringing in their insights and their expertise into the data itself. Fourth, there's this operational focus. So maybe we'll get something into production. That's kind of the goal here, right? I once had a professor in grad school who said something along the lines of, a theorem is only as good as its best application. So I was, of course, a pure math student, but he was an applied mathematician. And at the time, it always rubbed me the wrong way. But as I've progressed through my career, I've learned to appreciate this quote. And I think it applies to, data problems in general, that if you're not getting things into production and they're not having an impact on the business, it's kind of meaningless. Like the notebooks you're creating that sit there in GitHub and don't do anything, if they're not making it in production, you may as well have not have created them in the first place. So everything in the modern data stack is very much focused around how do we operationalize things, how do we automate things, how do we get them into production, how do we make it easy. So I think that philosophy we can hopefully start to extend towards machine learning and just make it easy for you to actually get results out of your machine learning work. And then last, this low cost to iterate or onboard new use cases. It's kind of a combination of a lot of these other points. So the idea here is in the data science process, you often are looking at data sets and solving a problem, but you're not like, I want to add new features, I want to modify features, I want to change some configuration parameters or whatnot. So having like a well-defined tool set and ecosystem that makes that possible is very is very great. And so ideally, you could design an ML tool on top that would kind of adhere to that same philosophy. Okay, so another thing we can look at is like what tooling is available, and is this tooling good for the modern data stack, right? So I recently wrote a blog about the evolution of the machine learning platform over time. And this goes back about 10, 15 years, but like your first generation of tooling is what I refer to as collaborative data science tooling. So these are really tools that are kind of notebook focused, and the main goal is to bring users together to collaborate on like an enterprise level. So, notebooks, when they were first created, were just something you ran on your laptop, and are certainly useful, but for real enterprise use cases, you need to be able to collaborate, you need to be able to share code, you need to be able to run that code in a reliable way. So these platforms are really geared towards that kind of user. But they are not without their issues. Certainly, they don't have operational models. So these platforms tend to be the most general. They're very, being focused on a notebook, essentially, where we're trying to give you a tool that you can take and then do whatever you want in it. But by being that general, you're then making it very hard to operationalize, right? Like those are two sides of the coin, and we need to focus on one or the other. So lack of operational model, it's hard to productionalize these. I think anybody who's started with notebooks and tried to create a production process knows this all too well. So notebooks are notoriously difficult to productionalize, just arbitrary code in general. And these platforms tend to not help in that effort. Data scientist focused. So these tools are geared towards data scientists, which is great because they're selling to data scientists. But again, it would be great if we could open them up to more users who are able to come in and provide more insights and their data knowledge into the machine learning workflow. These tools tend to encourage what I call pipeline jungles. So essentially, you're left orchestrating like a lot of actions between this platform and other things in the system that you may need to do, like spin up containers to host models that are mounted as API endpoints that applications then use and stuff like that. So, a lot of harder stuff is left to the reader. And as a result, you need to hire a lot of experts like DevOps or data ops people or software engineers or machine learning engineers who are able to do all this hard lifting. So I think over time, generation 1 platforms have proven to not be great at actually bringing like business value into the organization. So the second generation is what I refer to as model-based point solutions. So these tend to be things like MLOps tools or experiment trackers, and also like some explainable AI tooling. So they're not notebook focused usually, but they are model focused usually. So usually the idea is like you're going to bring in your own model, and then you're going to like solve some piece of the operational workflow with this tool. The main thing that I dislike about these is it's hard to find good like end-to-end solutions in this space. And I think the graphic on the left here illustrates that well. So the graphic on the left here is like a bunch of tools that exist in like the ML space. So there's a bunch of categories, there's a bunch of different tools. Most tools exist in one category. As a result, if I want to do something end to end, I need to go buy like 3 or 4 of these and try to figure out how they work together. And that is incurring a huge technical debt on me, the user, into figuring out how this all works. They're also isolated from the data plane, right? And I think that's a big, big problem. So when you're starting with the assumption that we're just going to take like arbitrary models as inputs, like those models are obviously built upon data, but I'm not accepting that data. Like some of them may like accept CVS uploads or something, but they're detached from this model training process, which means like I have no ability to really control that like data skew problem that exists between like data training and serving the data up. And I think that surfaces a lot of problems. systems if you're trying to build like an end-to-end system here. Pipeline jungle still exists, so you're now kind of trading workflow orchestration tasks for like API and SDK acrobatics. So it's again a lot of technical debt that you're assuming on this journey. You're still leaving a lot of harder tasks to the readers. So, within the past couple of years, things like feature stores have become very popular for operational workloads in the machine learning space. They're not in this generation 2 ecosystem. So, I think over time we have determined that like these tools still leave a lot to be desired. So you can then do an analysis and you can say, well, how do these existing platforms mesh with the modern data stack? So we know the modern data stack is centered around cloud data warehouses. The existing platforms are not centered around cloud data warehouses. They are generally platforms that are just either not focused around data at all, as we see with a lot of the generation 2 tools, or the generation 1 tools tend to be much more generalist, where like they're connecting to like anything you want to connect to. And again, we talked about the trade-off that by being more generalist, you're making things a lot harder for the end user itself, because by being less opinionated, we're not able to do things as well or as streamlined. Modern data stack tools tend to be SaaS, or software as a service. So they're like managed services that are running in the cloud, and I don't have to install them. I don't have to maintain them. Most existing ML platforms are not SaaS oriented, or they at least didn't start SaaS oriented. Like most of the existing platforms started like in that big data, NoSQL decade, where most technology was being built out that was focused on, connecting to Hadoop, connecting to NoSQL databases, a lot of on-premise technology. Some of them have since shifted and like they now have like a SaaS offering, but even when you take a tool that you designed to run on-prem and you shifted it to SaaS, like you're still going to have a lot of like configuration or setup stuff to go through. You can never really uncouple all of the technical debt that you've created around that workflow. Modern data stack we talked about is focused on SQL. Existing ML platforms tend to be code-based, so they're expecting users to come in with Python or R skills instead of SQL skills. And a key one of the modern data stack here is that they have a declarative interface. So, this is again key to like the operational workflow, but essentially like how can you work with systems in more of a configuration based approach rather than like a workflow orchestration based approach. So the existing ML platforms work more on like, hey, we're going to build out a workflow using some workflow engine, and the modern data stack loves things to be much more declarative. So if you ever use DBT, like that's a great example of a declarative interface where you're essentially defining how you're working with the system in these declarative files, and then you are able to submit it into the system. And in DBT's instance, they then go to your data warehouse and build tables for you. Terraform is another example if you're from like the infrastructure as a service side of things, but they allow you to define how you're working with infrastructure and configuration files, and then they build it out for you. So that's a much different approach than this like pipeline jungle approach that a lot of existing workflows take. And again, existing ML platforms tend to be development oriented, especially like the Gen 1 notebook tools are very development oriented. I think even a lot of the Gen 2 tools, when you actually get down to them and you look at what they're doing, like AutoML or like various MLOps stuff, like a lot of them are actually more development oriented than they are like true production systems. So that's another thing to keep in mind as you start looking at all these things that exist. But for the modern data stack, we would love for things to be very much production oriented. And lastly, last point I'll make here is that I think something that people love about the modern data stack is that users of the system will often say it democratizes their data workflows. So by having all these things up top, it allows users of various skill sets and backgrounds to come and participate in various parts of the data workflow. So, I can have a data scientist come in and start working with my data analytics stack and make reports or whatever, because they just know how everything works. And it's very easy and it's very straightforward. I think if you look at the existing machine learning platforms, what they do is actually further silo your data workflows, right? Like, you're providing these very technical, complicated solutions that are very geared towards specific tasks in your machine learning workflow. And really, like, only a data scientist or a machine learning engineer is going to be able to use those tools. So, those tend to be very skilled employees, and there aren't a lot of them. So, if I'm running a company, I want to try to get as many people as possible doing the hard things. Okay, there is hope. The hope is that there's this new form of machine learning platform emerging, and it's this operational AI platform. So the advantages of the operational AI platform are many, but we're listing a couple here on the right. Declarative, so it does adhere to this declarative interface where I can essentially describe in a configuration file exactly how I want my machine learning workflow to run, and it will then go and build out my entire workflow for me. So that is fantastic. And it means that we're really lowering the bar of entry, because we're not saying like, hey, you have to use Python, hey, you have to use R to come in and use this. All you have to do is kind of understand a little bit about how the configuration of the system works, and then you can submit it in, and it'll take care of the rest of it. I think this naturally lends itself to being operational. The focus is on enabling production workflows and not giving you a notebook where you can, run a ton of different thought experiments on how best to solve a problem. I had the great fortune of working with Hillary Mason at Codera. She had she had something that she often would say, which is something like, data science problems, when they are set up appropriately, they fall into one or two categories. One is they are trivial, or they are close to impossible. And I think, as I, over the past decade or so, have worked on a variety of machine learning problems, I think that is true. I think, you get to a point where you have enough experience in this field that you essentially are saying, this is an unsolved problem that nobody knows how to do. So, it's basically close to impossible. I'm gonna have to sit down and do a ton of research to figure it out. Or this is a fairly straightforward pattern, which I've done before, I've seen before, solutions out there is known, and we can apply existing methods to doing that. So I think the conclusion after you work in this mindset for a while is that you want to take all of those easy known problems and just automate them and make them as operational as possible. So, we can do things I don't have to recreate customer churn solution from scratch every time I get one, because I've solved it 20 times in the past, and I just want to automate that as much as possible. And there's a couple of things you probably want to look at when you're approaching this problem. But other than that, I can be pretty confident that I can fashion an automated solution that'll be able to churn out pretty good predictions. These solutions, I think, are great at democratizing your ML workflow. So you're able to take all of your users who are part of your data process and really give them a tool that they are able to then use. They shouldn't have to be experts in machine learning. They really should be experts at your business and experts at your business data. And the tool should be the machine learning expert that they then use in order to start to get predictions out of things that they know. They know what a sales forecast is, right? They may not know how to build a model that does it, but they know where the data is and what they want to predict. So we should try to enable that as much as possible. So GitOps friendly is probably the number one thing in my long tenure working in machine learning that I often hear. Companies are like, oh, well, why can't I just do a PR and the system will build everything for me? With an operational AI system, that actually kind of is the end goal. The end goal is we're declarative, we're automated, everything's operational. So do a PR and it will build everything for you. And I've just talked to so many large enterprises over the years who have essentially had that exact request, which is just like, hey, I want to version everything in Git. I want to just do a PR and have my workflow built for me. So you can look at this operational AI platform. I think there's 3 key features that you have to have. One is this feature store. If you're not familiar with feature stores, I would invite you to do a Google search and read up about them. They're super important. But essentially, like what this is a way for you to easily define and share features within your organization. I wrote a blog about a month ago on why feature stores are super great for Continual. So if you want to, you want a resource for that, I would recommend my own blog. But there's a lot of people who have written great stuff about feature stores. So this makes it super easy for users in your organization to come contribute their own data knowledge into your system, and you can then start applying that to your machine learning problems. And I think they also, if designed correctly, allow users to start thinking about machine learning problems, not in terms of like tables and files, as you often do, but in terms of business concepts like customers and sales and projects and stuff like that. So I think feature stores are great. The next one is a declarative AI engine. So we talked about the strengths and the need for this declarative approach for an operational AI platform. A declarative AI engine is going to streamline building, iterating, and tuning, models very quickly. You're going to be able to deploy them super fast. We talked about how integration tools in the space will allow you to move data into your data warehouse, like all in the same day that you get started, which is actually true. Like I've done this myself. You can sign up for an account, connect to your warehouse, and actually like start ingesting data that day, and it just works. There's like zero you have to do. And I think the same is true for this operational AI platform. I should be able to sign up, create an account, and then just start building models directly off of data that I already have in my data warehouse. It's well curated, and get predictions today. I shouldn't have to wait, shouldn't wait months to operationalize this or to get this into production, which is the reality, I think, for a lot of enterprises today. And then last is this, what I would say is a continual ML ops or explainable AI interface. So, key observation about real production machine learning is that it's not a one and done activity. I think a lot of data scientists tend to take the approach that, hey, I built a model in a notebook, I'm done, mission accomplished. And the reality is your data is changing behind the scenes. You're going to need to retrain your models. You're going to need to create new predictions as new data comes into the system. So maybe I'm doing quarterly sales forecast, or maybe I'm doing weekly item demands, or I'm doing daily predictions or daily recommendations for my application. These are things that are continually changing. So we need to be able to detect data drift, detect model drift. We need to be able to explain why our models are making the decisions they're making using explainable AI. We need to be able to detect bias that's happening in our models. All of this is doable today, and a lot of it is because of all the technology we've created in the Gen 1 and the Gen 2 platforms. It's just a matter of like applying it all in the right way for the end user, right? And I think often when I talk to data scientists, they're kind of hesitant to embrace automation. And I think that's a key mistake that a lot of them make. So, in my software engineering days, I think what's certainly true is software engineers embrace automation and they love it. And they use it as a means to like automate the things that they don't want to do, or the things that take a lot of time, and they're just interested in the end result. And I think we should look at machine learning in much the same way. Like, I'm very interested in the end result of things like ML ops and explainable AI. I don't want to spend a lot of time like manually computing all this stuff. But this is stuff that you can just easily start to automate off, and an operational AI platform should be doing this for you. Okay, so just a brief note about what we're doing at Continual, if it's not already apparent. At Continual, we are behind the scenes making the very first AI platform for the modern data stack. So it is very much this operational AI platform. It's very much working in this ecosystem where the assumption is you are a cloud native company, your data's in the cloud, you're embracing this new trend of doing everything in the cloud, being operational, being declarative, not having to manage your technology stack. All of this stuff is, I think, super great, and I think allows companies to get a lot more value out of their data and their data teams. So if we go back to that example architecture, it's technology that fits just directly on top of your data warehouse. So we read tables from your data warehouse. We're able to make predictions out of your data warehouse and put them back into your data warehouse. So we're not storing your data. We're not duplicating your data. There's nothing like that happening. It adheres to all of those great benefits of the modern data stack that we talked about before. You don't need to know Python or R to work with it, and whether you need to know SQL. So we're able to take your SQL and apply that and build all the models for you. It's operational in nature. We are automating all this stuff behind the scenes. We talked about, you get a feature store, you get this declarative AI engine, you get explainable AI and continual ML ops. So everything, meshes just very well with this modern data stack ecosystem, and you should be able to get started and get results in a day or less. That is the promise, which I think sounds crazy to a lot of people. And I was talking to a customer a couple of weeks ago, and they had said, this was a data scientist, and he had said, if you had told me I could do declarative AI a year ago, I would have said you're crazy. That you can never get AI down to a configuration file. But after he had been working with DBT for 6 months, he was like, yeah, I totally see that this is now like a possible thing, and like all data should really be dealt with in this fashion. So I thought that was really insightful, that as you start working with other tools in the ecosystem, you start to kind of see the opportunity and the vision played out kind of in different use cases. So like DBT is focused very much on data transformations, but you see like, oh, well, this approach actually, like, why can't we apply this to machine learning or AI? Okay, how does it work? Just very briefly, we connect to your cloud data warehouse. Users then spend most of their time just declaring features and feature sets, which are collections of features, and models. So you use SQL to essentially just point at data in your system and connect it together. And we can then use that to build out models in the system. And those models then will pump predictions back into your data warehouse. So these can be, this is then done on a continual basis, right? So you in the system define how often we need predictions. So is it monthly, weekly, daily, hourly, every 15 minutes, whatever. So model refreshes and prediction refreshes, or incremental prediction refreshes, will happen, per user definition. So that's really it. We're live now, so if you're interested in checking us out, I'd recommend going to our website, continual.ai. Get in touch. We are currently, getting people onboarded and using the platform. So it would be great to work with anybody here. All right. Let's check out questions.
If anyone has questions for Jordan, please submit them into our stage chat room, please. Great presentation, Jordan. Very informative.
Thank you.
And Jordan will continue to watch the chat as we move into the next phase. Oh, here we have one from one of our viewers. Here's the blog that Jordan was referring to. And there's the link. Thank you, Beth Ann. Very appreciative. And Jordan, if you want to monitor the chat as we move through to our next stretch break and on, if any other questions come through on the chat, you can answer them also directly.
Okay, will do.
Great.
Thank you.
Thank you so much. Much appreciated. Okay, folks, we'll take a quick break, about a 10-minute break. We'll be back at 20 past the hour, and we will bring Igor Markov, a research scientist from Facebook, to your audience. See you in 10 minutes. Bye-bye.